Good morning, everybody. Today we have our lecture on business intelligence, WIN6, 28th of November 2024. Today we will be talking about a concept called nemawashi. You know, I spent several years in Japan as a production leader for a German car company with a star logo in it, and I got to know Japanese management concepts pretty much for odd, so in very much detail. At the same time, some years later, I was doing my PhD, so I decided to write about it, to put that in papers. And I gave a conference in 2015 with some colleagues from Bosch, and the conference is published here. This conference was given in, I think, in Norway. I don't remember anymore. So you can download the paper there in this address here. Okay. I totally recommend that you do it and read the paper, because this is part of the exam, and the concept that I give you today is only one part. Also, the paper is part of the exam. Okay, so please download it and read it carefully and try to understand what goes on there. So we go and explain the concept of nemawashi and implement an example of it. Nemawashi, it's a Japanese word that means to prepare the ground. Okay, prepare the ground. So whenever you plant a tree or plant some plant in the okay, so you have your tree, you want to plant it, you need to make a little hole in the ground and put some adequate soil for the tree to be successful, right? So if we take that as a metaphor, in Japanese describe things with metaphors many times. So the tree would be the organization, and in order for the organization to be successful, you need to prepare the ground adequately. So this is your management task. Okay. So with this method, we describe organizational dynamics okay. We do so by transforming the information contained on or in the KPIs from the management system. Okay, KPI is a key performance indicator. And so the hypothesis what we need to start, okay, is that there is a list of KPIs given with values at different time stamps, time points. So, in other words, we have access to the management system which is a list of KPIs as a function of time, where E is can be 1 to infinite. Okay, so you can have as many KPIs as you want. Remember that each KPI represents, or not represents, describes only one part of the variability of the system. Okay. If you take the system, like let's say a production process or something like that, or a factory, like imagine it, you can picture it as an orange, okay? Like your system, your factory, or your business, or whatever. Okay, this is your funny factory. Take it as an orange, okay? And you try to describe this orange, and you look at it from the perspective of the production leader. So you have one KPI that is productivity. Okay, let's say green. If you ask the production leader, he will tell you that the factory, the orange is green. Okay, but if you ask the quality manager, his KPI is going to be quality. Let's say this is lilac. He will swear that the quality, that the factory is lilac. And if you ask the controlling guy, he will just look at the cost, and he will kill if you try to convince him that the factory is nothing more than cost, and so on and so forth. So the fact of the matter is that each KPI represents some part of a bigger whole, some part of the reality. This is called variability explaining, and this is what we do. This is the reason why we do the principal component analysis. Have we seen the principal component analysis in this lecture? Hello? Okay, so we will do that in the next week, okay? So just remember, this is a disclaimer for next week. It's called PCA, Principal Component. Maybe you want to Google it, analysis. When we look at the lecture next week, you need to come back here, okay? So every KPI describes only a part of a system, and we measure variability in statistics in a simple way, like the variance. This is the second momentum of statistics with reference point the mean value, okay? This is the variance, or with the standard deviation, sigma, which is the square root of the variance. So this is the way we measure variability, okay, of a KPI. The thing here, and you need to understand this in a deeper way than just looking at the formula. The thing here is that the intrinsic meaning of variance is to be the square of the distance between the points and the mean value, right? This is what this formula is saying. This is the distance and this is the square, okay? For this reason, if we have many KPIs, some on the thousands, some on the hundreds, some on the tenths, and so on, we cannot directly compare them without previous normalization. Okay, so if we have here cost, and we have here, we are talking about, let's say, 10 to 20 euros of the product, and we have here the ppms, and we are talking about here 3,000 to 5,000 ppms, and we're talking about productivity, which is let's say 200 to 300 parts per day. Okay. The distance in this KPI is not the same as the distance in this KPI or the distance in this KPI. So when we measure variability and we want to compare variabilities in the system, okay, not only one KPI, but the whole system, the first thing we need to do is to make the KPIs comparable. Otherwise, we are fuckily fucked, because we're comparing one thing which is in kilometers and one thing that is in millimeters. And that doesn't make sense from a physical perspective, okay? This is super important. All right? Super important. Write it on your toilet paper, okay? And every time you go shit, you read it, okay? Whenever you have a system of KPIs, you need to, first thing you need to do is to make them comparable. How you do them comparable? You normalize, okay? We will do an example right away, but this is very important. If I see that you don't that you resolve this problem in the exam, but in the case I ask it, but you don't normalize first, you get 0 points, okay? Because then you show that you have not understood what is going on, okay? So let's look at an example. This is the way to learn this. A KPI system of a factory is 3-dimensional. Of course, I don't need to tell you that all companies in the world have such KPI systems. So with this method, you can describe the dynamics of a company, like let's say with 5 lines of code, and give your boss or your upper management an analysis that otherwise would take them many months, okay? So this is universal and it's very useful. Yeah, if you use this method, please remember that I gave you the concept because it's my intellectual property, okay? So you need to cite it. It's 3-dimensional and has following data. This could be a question in the exam, okay? So like this. Quality, it's big Q, is measured in ppm. Delivery rate, DR, is measured in percentage. And cost, C, is measured in euros per unit. Okay? So just 3 KPIs. We are not here in a management lecture, so I will not dive into the meaning of a KPIs or so. Just so we have here the calendar week 1, calendar week 2, calendar week 3, calendar week 4, and calendar week 5. Then we have 3-3, 2-7, 18, 15, 13, 91, 93, 89, 92, 95. And then cost 17, 18, 16, 15, and 16. So as you can see, as you can imagine, just remember what I just said above. A distance between 3,300 and 3,301, which is a distance of 1, is not the same as a distance between 16 and 15. Okay? Because the scale is different. So what you need to do is normalize. This is the first step. Remember, otherwise you are doing bullshit. You don't understand what you're doing and then it's not worth it. Okay? So the first thing we do here is, and you need to explain this in the exam, first step is normalize on the time axis so that KPIs are comparable. All right? This is the first step. Remember, why you do it, it's as important as what you do, so you need to explain it, okay? So we can normalize in two ways. The first normalization, it's called the normalization towards normal distribution. We subtract the mean value and divide it by the standard deviation. The second way of normalization is to get the value, subtract the minimum of the series, and then divide it by the maximum minus the minimum. We will do this. This method because it's computation-wise easier and faster. Okay? But you can also do the other one. It doesn't change anything. So we do normalize the second way. And this is the first normalization. We will do two normalizations. So the Q star, the normalized quality. Then we get a normalized delivery rate. We get a normalized cost. Okay? How do we do it? Let me do it for you. So again, we have calendar week 1, in English, calendar week 1, calendar week 2, and so on. So how do we normalize the values of calendar week 1? So we take the value 3,300 minus the minimum of the series, which is 1,300, divided by the maximum value, 3,300, minus the minimum of the series, which is going to be 1. Okay? So we normalize on the x-axis, on the time axis. So So in this axis, so like only quality, delivery, and then cost, okay? So the next value is going to be 27 minus the minimum divided by the maximum minus the minimum, which is going to be 0.7. Calendar week 3 shall be 1800 minus 1300 divided by 3300 minus 1300, so equals 0.25, right? So calendar week 4, 1500 minus 1300 divided by 33 minus 1300, 0.1. Calendar week 5, 1300 minus 1300 divided by 33 minus 1300. It's going to be 0. Okay, you will notice whenever you normalize like this, the biggest value is going to be 1, the smallest is going to be 0. But it makes distances comparable. Okay? So remember, it makes distances comparable. So you are able to later on compare the KPIs. Otherwise you won't. If you don't normalize this way, you get 0 points. Okay? Is it understood how to do it? Any questions? I mean, it's not super difficult math. It's just like adding and subtracting and stuff. Okay? All right, so let's hit it for the delivery rate. So our first value is 91. That's also, no, the smallest value is 89. Good, then we take 91 minus 81 divided by 95 minus 89, so 0.33. Then 93 minus 89 divided by 95 minus 89 equals 0.66. Next, 89 minus 89 divided by 95 minus 89 equals 0. 92 minus 89 divided by 95 minus 89 equals 0.5. 95 minus 89, 95 minus 89 equals 1. And the last, the cost is 17 minus 15 divided by 18 minus 15. 0.66, then 18 minus 15 divided by 18 minus 15 equals 1. Then 16 minus 15 divided by 18 minus 15 equals 0.33. Then 15 minus 15 divided by 18 minus 15 equals 0. And then again 16 minus 15 divided by 18 minus 15 equal 0.33. So we have normalized. Now we have all the values between 0 and 1. Okay, you see 0, 1, and the rest in between. Now we can compare the KPIs. We have not lost any statistical information from this list of KPIs. Statistically, from a statistical perspective, the variability the variability explained by these KPIs is the same as by the original. Okay? Exactly the same. The only thing that has changed is that now we can compare the KPIs. So we have a system that we can represent. All right. Any questions? Any questions, please? No? No questions? So, all right. Well then, I mean, it's not really difficult, okay? It's just adding and subtracting. So the second step, but the important part is that you explain and you understand why we do it, okay? Not that you do it, but you need to understand why we do it. So the second step is we want to graphically represent the dynamics of the system, okay? And we could do it already with the first normalization with a three-dimensional plot. Okay, so we could take, let's say, the one axis would be, I don't know, the quality star, okay? One other axis would be the delivery rate star, and one other axis would be the cost, okay? And so we would take these values, 1, 0.33, and 0.66. We would take, let's say, 1. So this is 1 here, 1 here, and 1 here. So it would be like 0.33. So this point, and then 0.66. So the first point, the calendar week 1, would be this point. Okay. Second point would be, so this is let's say 1.033. Second point would be 0.7, 0.66, 1. So 0.7, 0.66, 1. So this would be calendar week 2. So the organization has moved from calendar week 1 to calendar week 2 that way. Okay. And the third point would be 0.25, 0.23. So somewhere here would be our calendar week 3, and so on, right? What you see here is that this is a 3D representation, and this is not very intuitive. This 3D representation is not intuitive, and is difficult to derive a business conclusion from it. Okay. So it just, I mean, we could do it, but it's not very cool. It's not really what we're looking for, because we want to do something for the business, right? So what we do is we project the curve from 3D to the so-called simplex 1 in 2D. So what does this mean? From a graphic perspective, okay? So take it from a graphic perspective. What we do is we take the 3 axes, because all the values, let me do it correctly. All the values are between 0 and 1 after normalization. We take the 3 axes, one, and 1. We have our curve as we painted it, somewhere here in the space, okay? And what we do is we take the plane, the simplex is called the plane that cuts all these 3 points. That cuts the points that are the ones, okay? So this is a plane. Okay. So I said the organization is moving here. It's moving in time, and each point is a point in time. Okay, just as we describe here, calendar week 1, 2, 3. Okay. And what we do is we project this blue curve onto the simplex, the triangle, cutting the points of 1, of value 1. So it's called the simplex 1, okay? So our graphic representation after projection would be something like this. Say this is quality star, this is cost star, and this is delivery rate star. We do a projection. We will learn in a minute how this is performed. We do a projection, and then here we have quality star star, cost star star, and delivery rate star star, and the axes here are like this. So we have 3 axes in one graphic. Okay, they cut in the middle, and then we get our curve with timestamps. Okay, so we know in which direction it's moving, and then we can derive business information from it. So this is the plan. Questions on the plan? No. It's just, this is just to make it pretty. No. We will see this example how it takes. It would be great if it would be like a little spiral inwards. Okay, because this means that the KPIs are getting under control. Okay, because they don't move. Okay, they are always closer to each other. See, if the KPIs in calendar week 30 are closer to the KPIs in calendar week 31, this means that you have your company under control. Okay, You still there? Hello? So this makes sense what I'm saying? So if sometimes, I mean, sometimes it's like this. You have 1 week, you have here. Second week, you have here. Third week, you have here. Fourth week, you have here, right? So you don't know what the fuck is going on. It's impossible because you are, every week you're somewhere else. So it's impossible to know. So then there is business implications from it. So, but we will see that in the next step. Okay, just let me finish how to paint the curve. Okay. After that, we go to the business interpretation. So, we all the points in the simplex one have coordinates that add up to 1. So the sum, meaning the sum of their values add up 1. And this is the reason why we take the simplex, okay, basically. So what we need to do as a result, what we need to do is normalize the values of each timestamp between 0 and so that they add up 1. Okay, so now we take not vertically. Now we take each week, okay, and we make it so that it adds up to 1. So now we have Q star star. We have delivery rate star star. We have cost star star. We have calendar week 1. And how do we normalize it? So, well, we take the value of quality which is 1, okay, 1. And then subtract the sum of all the rest. 1 plus 0.33 plus 0.66, meaning we have a value of 0.5. Then we take the value of 0.33 divided by 1 plus 0.33 plus 0.66. It means we have 165. So we take 0.33 and divide it by this plus this plus this, okay? And then we take the value of 0.66, 1 plus 0.33 plus 0.66, meaning we have 0.33, okay? So now if you add up these values, 0.5 plus 0.165 plus 0.33, you get, after rounding, you get 1. And this is crucial because now we can paint it in the simplex. Okay? Again, we don't lose any statistical information. if I ask this in the exam, you need to give me all the calculations. Don't think you can skip the calculations, because then I think that you have looked around and cheated and you didn't do it. Okay? So even if you know how to do it, if you don't have speed, you have a problem. Zero 1 divided by 0 1 plus 0 5 plus 0. 0 5 divided by 0 1 plus 0 5 plus 0. 0 0 1 divided by 0 plus 1 plus 0 33. 0 75. 0 plus 1 plus 0 33 equals 0 25. Okay, so this is the normalized after the two normalizations. If I ask this into this exam, you need to not only do it, you need to explain why you do it. Okay? I mean, I can repeat it many times. Some people still don't do it. So we have normalized each KPI between 0 and 1 so that we can compare the KPIs. Now we have normalized each point in time, and now we are ready to represent. All right? Any questions on this normalization? Look, if I want to put these three numbers, okay? And I want them to add up 1 later. Okay, I take this first one divided by the sum of all the three. I give you an example, maybe here. Wait. So if I have three numbers, let's say 3, 7, and 6, okay? 3 divided by 3 plus 7 plus 6 plus 7 divided by 3 plus 7 plus 6 plus 6 divided by 3 plus 7 plus 6 equals 3 plus 7 plus 6 divided by 3 plus 7 plus 6 equals 1. You cool? All right. So yeah. So we want to bring them between 0, between we want to add them all the three numbers to add up 1. Okay. All right. Yep. No problem. So I leave it here as example explanation. Okay. Of what we do. All right, so we have this data and now we want to represent them into our simplex. And now you will notice why it's so good to have the video or the YouTube video of this lecture. Because if I would give you this information in one PowerPoint, you will be probably lost in translation. Okay, so because you have the video, you can pause it, you can move it, you can play it many times, and it will help you understand. So no, it costs you money. Yeah. Well, yeah, that's a good question. I already said that in the first lecture, but if you're only attending online, probably you didn't get it. See, the official language of the exam is English, okay? So officially is English. If nobody, let's say, complains, let's say you don't complain and your colleague, your other students, your fellow students don't complain that you have an advantage because you are answering in German, then I don't care. You can also answer in Japanese if you want, okay? I really don't care. I'm testing you on the content, not on the on the language, okay? Yeah. No. But if one person complains because I don't know, because they, I mean sometimes there are people that are weird and they want to have, I don't know, they want to complain and they want to look for problems and create problems for others. I have experienced this already. If only one person complains, then I need to correct all exams again. And so it's your call. If nobody complains, I don't have a problem. So you can answer in German. I will not put you worse because for me it's no problem. I am testing your knowledge, not your English skills. Okay? Okay, this makes sense. So I need to be careful with what I say, but I think this is very reasonable. But of course, if somebody I don't know how you say it in German, if somebody cracks my balls, then I can also be an asshole. I don't know how to put it. Okay, so does this answer your question? Yeah, no problem. So yeah, so last year was in German because all the students were from Germany, so that's why. So we take the KPI Q star star, okay? All the points in this triangle, all the points, whatever point you pick, has the property that the adding up the values of cost star star, quality star star, and delivery rate star star add up 1. So we only need to take, in reality, we only take 2 of them, okay? So the axis of quality goes a little bit like this. Okay, I'm not making it with the rule. You don't need to do it with the rule again, okay, in the exam, just approximately. This point is quality star star 0, okay? And this point is quality star star 1. And in the middle somewhere, you have there you have here quality star star 05 and so on. Okay, and for delivery rate is the same, so we have here delivery rate star star 1. Here we have delivery rate no, I guess this is the point where they're meeting is 1/3. Here we have also delivery rate star star 1/3 because of the geometry of the triangle, and this is delivery rate star star equals 0. Okay, so we only take these two axes because the third one is given. Let's look at the points. We have the point 0.5 and 0.165. Okay, so the calendar week 1 point is 0.5, which will be somewhere here, 0.5 in quality. Okay, and all the points parallel, all the points parallel to this line, As I said, you have the videos and you can look at the videos and compare. All the points parallel to this line are all quality. This is the line quality star star 0.5. Okay, it's parallel to this one. And then we have 1.65. Okay, so we have the line 1.65, which is somewhere horizontal because it needs to be parallel to this. I don't know, somewhere there. This is the line giving you delivery rates star star equal 0.165. Okay, where these 2 points meet, these 2 lines meet, you have your calendar week 1. All right. So we cool? Did you get it? Doesn't matter if you didn't get it. Let's do the next point. Okay. So 0.297, 0.28. 0.297 on the quality star star. It's like around 0.3, so it's going to be somewhere around there. Okay. So this is going to be quality star star 0.97, 295 or 297. All right, so that's the line we're looking for. And then 0.28. So 0.28 is going to be around here. 0.28 is going to be again around here. Okay, so this is the delivery rate star star 0.28. So our calendar week 2 point is going to be where these 2 lines meet. All right, so this is the calendar week. Calendar week 2. Okay. Yes, because all the points on this simplex, on this triangle, add up to 1. Okay, so if you have quality plus delivery rate plus cost equal 1, I set up this one, the the last one is already given. Okay? Does it make sense? Because I just do 1 minus. Yeah. You can choose whatever is faster. Yeah. So now you can say that the company is moving from this point to this point. Okay. Is that cool? All right. Well, then let's do the next one. 0.43, 0. All right. So 0.43 on quality gonna be somewhere here. Okay, somewhere around here, let's say. 0.43. This is the quality. No, sorry. This is the quality. The line for quality star equals 0.43. And the line for a little longer. The line for delivery rate equals 0. Wait. The line for delivery rate equals 0 is this one. Okay, so our third point is going to be where these two lines meet. This is our calendar week 33. Calendar week 3. So our system is moving like this. All right. Yeah. Don't be sorry. Yeah, just hit him. Yeah. Yeah. Mm-hmm. Yeah, that's a good question. It's this representation. This distance is not linear. Okay. So this point is 1/3. The rest is 2/3. That's because of the geometry of the triangle. Okay. Yeah. It's 3D. Yeah. So just you're cutting like a cheese. You're cutting the 3D like a cheese, okay? So you're looking at a triangle in 3D. Okay? So it's a little bit challenging, but once you get the grasp of it, it's really cool. So the calendar week 4 is 0167. And then we choose the C ** because we have a 0 there, so which is very useful. So now we take the 0167 for Q ***. 0167, which will be somewhere, I don't know, here. Okay. So this is Q ** 0167. But now we take the cost point, which for the cost, the point of cost 0 is going to be somewhere there. Okay. So this is the line for cost 0. No. Let me paint a line for cost 0 here. Red. No. What the fuck am I doing? Let me. So the line for cost 0 is this one. Okay. So this is the line for cost star star equals 0, which is this point. Okay. And then as a result, we get the value of our, as you see, the company is bumping around. So we will need to understand later on what this means. All right. And then we have the calendar week 5. We have 0 on the quality and 0.75 on the other one. So we have 0 for quality, which is this line. This line is the line for 0 quality. Okay. And then 0.75 on delivery rate. Which means something like this. Okay, so this is the delivery rate star star 0.75. And that's why we're moving from calendar week 4 to calendar week 5. Okay. So this is the solution of our system or the system dynamics. We're moving like this. Okay, if you want. Any question? Yeah. If you let's do it. If you take the cost line here, this cost line is the line for cost 0.25. Okay, because it's 0.25. So you have cost star star, it's 0.25. Which means that 0.75 plus 0.25 plus 0 equals 1. Okay? Okay, so any questions? So now, as I said, this point in calendar week 5 is 0, 0.75, 0.25. Okay, just 0, 0.75, 0.25. Okay? Any questions? Please ask. Or feel free to ask, I guess. Okay, if no questions come, then we go and interpret. Step number 4, okay? The system is in alignment. You can read about this in the PDF I sent you, or you have above. Is in alignment, and this word is super important, okay? We saw it already in the first lecture of the series. The word alignment you need to understand if you want to do some business. The system is in alignment on a time point t sub j if the distance between t sub j minus 2 minus t sub j minus 1 bigger or is bigger than the distance between t sub j minus 1 and t sub j. So this is the definition, okay? So the distance between calendar week 1 and calendar week 2 is smaller than the distance between it's a little bit smaller, I think, at least in my drawing. You can measure that, okay? Between calendar week 2 and calendar week 3. So, because the distance is increasing in time, the distance increase. So we have no alignment in the system, okay? In calendar week 3. So the distance between calendar week 2 and calendar week 3, I put it in absolute value because is again smaller than the distance between calendar week 3 and calendar week 4. Okay, so this distance is smaller than this distance. So again, no alignment in calendar week 4. And the distance between calendar week 3 calendar week 4 is bigger than the distance between calendar week 4 and calendar week 5. So alignment in calendar week 5. Okay? Without this interpretation, the whole work is not worth it. because you're not able to interpret anything from it. Okay? What we're looking for are systems that have a distance in the simplex that always becomes smaller and is within a specific radius that we have our values in the always within the radius. So if we have that, we can say that our system is under control. If our system, factory or business or whatever, is or remains within the limits of a circle of radius epsilon towards 0, then our system is under control. So this is good. Good for business. Because if we have our variability under control, we can plan, and as a result, we can be successful. All right? That's it.